In the fourth question of this series, where we learn how to find the maximum using linear programming, we're asked, a company manufactures bookshelves and desks for computers. Let x represent the number of bookshelves manufactured daily and y the number of desks manufactured daily. The company's profits are $25 per bookshelf and $55 per desk. The company should not manufacture more than a total of 80 bookshelves and desks per day. So let's write that down. That's one of our restrictions, our constraints. So x plus y cannot exceed 80. To meet customer demands, the company must manufacture between 30 and 80 bookshelves per day inclusive, which means that x representing the bookshelves, it must be greater or equal to x, but less than or equal to 80. That's another constraint. Furthermore, the company must manufacture at least 10 and no more than 30 desks per day. So y is sandwiched between 10 and 30. How many bookshelves and how many desks should be manufactured per day to obtain maximum profit? What is the maximum daily profit? Now, to do this question effectively, we have to let z, which equals to ax plus by, be an objective function that depends on x and y. Now, we're told two important things at the beginning. We're told that the company's profits are $25 per bookshelf and $55 per desk. And we can represent this as a rate as our objective function, where we have z is equal to the rate of x, and that's $25, plus 55 per desk. Furthermore, z is subject to a number of constraints, and those are mentioned right here. To find the maximum profit, we have to a, graph the system of inequalities representing the constraints, and then find the value of the objective function at each corner or vertex of the graphed region. So once we graph these inequalities, you'll end up with lines, and those lines will intersect each other. We have to find out the points of intersection for each of the graphed regions. Once we find those points of intersection, we can substitute them back into this equation to see which one will give us a maximum profit. But if they were looking for the minimum, we would look for the smaller number once we've inputted those points of intersection into here. That being said, let's start with step 1, where we graph the inequalities. The equation x plus y is less than or equal to 80 is easy to graph. In fact, all we do is we solve for y, where we have y, and we'll replace this inequality with an equals 80 minus x. We'll graph that in a moment. These two, on the other hand, are tricky to graph because 30 being less than or equal to x is an equation in itself. X is equal to 30 and x is equal to 80. For this one, we have y is equal to 10 and y is equal to 30. So technically, we have 5 equations that we need to graph. In other words, 5 lines. Now, since we already know how to graph lines, I'm going to show you what these would look like on an xy plane. Notice that we have 5 lines. The diagonal line here represents y is equal to 80 minus x. This vertical line represents x is equal to 30. This one, x is equal to 80. This one is y is equal to 30. And here we have y is equal to 10. We have 1, 2, 3, 4 points of intersection. The point of intersection here is simple. That's 30 and 30. So I'll label this 1. The point of intersection here is 30 and 10. This one we'll call 3, and this one 4. To find 3, I'll substitute the point 70 x into here. If I substitute 70 into here, I'll end up with 10 as my y. So we have another point at 70 and 10. And this point can be found by substituting y is equal to 30 into this equation. Substituting 30 here, we have 80 minus 30, that's 50. So x is equal to 50, and the y coordinate is 30. Now that we have our points of intersection, we will substitute these into our objective function, which, if you recall, was z is equal to 25x plus 55y. Let's go ahead and substitute these points. Starting with the first point, we have z is equal to 25 times 30 plus 55 times 30. Number 2 will be z is equal to 25 times 30 plus 55 times 10. 3 is z is equal to 25 times 70 plus 55 times 10. And finally, for our final point, z is equal to 25 times 50 plus 55 times 30. Calculating the first one, you'll end up with 2,400. The second one will give you 1,300. The third one, 2,300. And for here, we get 2,900. What this is telling us is that in order for us to profit 2,900, we need to create 50 bookshelves and 30 desks. And there you have it. That is how to find the maximum using linear programming.